All right, this is the combinatoric analysis of the knife juggler problem. Here represents our 4 targets at the top. 1 green, that's the guy we want to hit. 3 red, those are the guys we want to miss. To figure out probability of at least 1 knife hitting green, we got to figure out the probability of 1 knife hitting green, which is obviously 1/4. Probability of red, by extension then, is 3/4. And now we have to figure out all the different scenarios that we can come across. Since we're throwing 2 knives, it's going to be just whatever the first knife hits and whatever the second knife hits. So first scenario is the probability of the first one being green and the next one being red. So the probability of hitting the green first is 1/4. And since the second probability is dependent on the first, we have to multiply them. And we know the second one is a red, which is a probability of 3/4 of happening. So the probability of hitting a green and then a red with a knife is 3/16. Scenario B is the same, just reversed. Probability of hitting a red then a green. We know it's 3/4 to hit a red. The second probability is dependent on the first, so we multiply them. Probability of a green is 1/4. Also 3/16. Scenario C is the probability of both green, which we know is 1/4. They're dependent. Second one is 1/4. 1/16. Scenario D is the probability that we suck. Both red, which is 3/4 times 3/4, which is 9/16. If we did this correctly, then this should cover all possible scenarios, which means that these add up to a 100% probability. So we get 3 plus 1 plus 9 equals 16 out of 16, and we're good. So now the probability of at least 1 green is going to equal the sum of all the possible scenarios that involve a green being hit. So A involves that, B involves that, and C involves that. So the probability of those are 3 plus 1 all over 16. They have a common denominator, so we can just sum them in the numerator, which is 7/16, which works out to be 43.75%. Get fucked.